All right, so here we go. Now, rolling here on the camera. So we talked about yesterday, we said that the metric system was based on water. You remember that? That was one of the last things I said, so I'm going to zoom the camera over here on me. And we're going to talk about this. Ready? At your desk, there's a meter stick, right? It looks like this, correct? This is a meter stick, and I'll get you one. This is a meter stick. This is about how long, this is how long a meter is, right? And if you look at this meter stick, you can see that I am and if I go up to here, 1.82, 182 centimeters long, okay? So what does that mean? When we talk about the meter stick, it's part of the metric system. And the metric system is based on water, and we're going to show you how. Now, let's say I had this meter stick, and I laid it down on a piece of paper, okay? And I'm zooming in now because it wouldn't be this big. But if you look right here, you can see that there are 100 of these little marks, right, as we go across the meter stick. And about the width of your pinky is pretty reasonably close to the length of a centimeter. Does that make sense? Can you guys see that? Okay, about the width of your pinky, that's a centimeter. So if I had this laid out and I made a mark on my paper, like I want you to make in your notebooks right now, and I made a straight mark like that was 1 centimeter long, then that'd be a 1 centimeter line, okay? Now, in reality, in your notebook, it's going to be about the width of your pinky. So you guys take your meter sticks right now and make yourself a line on your piece of paper that is 1 centimeter long sideways, okay? It's about the same width. It's about the same width as the lines are apart in a notebook, okay? So you're going to make a line like this, 1 centimeter long, and they're going to make another line like this that's 1 centimeter long, okay? So see if you can do two that are perpendicular to each other, okay? I'll put a little sign here for perpendicular. Now, if you're watching this at home, you can play it faster or play the YouTube video in 1.5, or you can just skip ahead because we're obviously working here, okay? So, 1 centimeter by 1 centimeter, right? Right? And now you can use your meter stick and go ahead and make it into a square. So if you're looking 1 centimeter by 1 centimeter means 1 centimeter to the second power. Everybody agree with that? What does to the second power, what do we call that? What do we call x to the second? X squared, right? This is why it's called x squared. Because you can make a square with two different measurements. Does that make sense? With two different dimensions. So you got a 1 centimeter square right now. That's the area on your notebook paper. Okay? So again, now mine is much bigger. Yours is only going to be about the same size as maybe a Barbie cup. All right? Now right in the middle of your square, make a dot. And then you can go up. And you can make another 1 centimeter square right here. Does that make sense? And you can freehand the next square if you want to save you time from working with that big old meter stick. Just try to do your best, make it look good. All right, now I'm going to take the top corners of the square and connect them, the bottom corners of the square. And now I have 1 centimeter width, 1 centimeter height, and 1 centimeter depth. So Jackson, what would you call 1 centimeter to the third? Yeah, that's 1 centimeter cubed. And that's why we call it cubed. You can literally make a cube out of it. Does that make sense to everybody? That's where the algebraic term cubed comes from. You can make a cube with 3 different dimensions. Does that make sense? Okay. So here's what I would tell you. You have this little cube about the size of a Barbie cup, okay? And we'll make one later in class out of paper. But you got this little cube about the size. You could put like, I don't know, 12 or 16 drops of water in it. Does that make sense? Okay, so let's pretend we did put some water in it. All right? I'm going to take some water right now. I'm going to just draw a drop. There, that's a drop of water. I don't know. Is that good? All right. If I take some water now, and I do this with it, watch. I'm going to take this water, and I'm going to put it into the cube. If I start putting water into the cube, then guess what? I'll keep adding drops of water until I fill up this tiny cube. And remember, this cube's about the size of a Barbie coffee cup. If I fill up that cube with water, can anyone have a guess as to how much water I have? It's just a little bit of water. It's this much water. Anybody got a guess? Guess what? You would have 1 milliliter of water. That's what 1 milliliter of water is. So when we talk about milliliters of water, like if you have a water bottle and it's a 500 milliliter water bottle, it means you could put 500 cubic centimeters of water. 1 centimeter cubed, another term for that is 1 cc. Does that make sense? So if you had an imaginary cube and you filled it up with water, the amount of water it would take to fill that cube up is called a milliliter. So a milliliter of liquid volume is the exact same thing as a cubic centimeter of space. A milliliter is a cubic centimeter. That's how much space it takes up. So see how the metric system is taking spatial volume and liquid volume and making them the same thing. Does that make sense? The last thing, we're going to take this cube, and the cube is full of water. I'm going to draw the cube more to scale here. I mean, this is actually bigger than a centimeter, but whatever. I got a centimeter cube of water here, 1 cubic centimeter of water, and now I'm going to put it on a scale. What do you think that electronic scale would read if we were weighing the water? If we weighed a milliliter of water or a cubic centimeter of water, how much would that weigh? Anybody have a guess? Think about the metric system. What? It would weigh 1 gram. So there is everything. A milliliter of water would fill up 1 cubic centimeter of space, and it would weigh 1 gram. It's all the same. The metric system is based on water, and it works. It's not like our system. So now we're making all these huge leaps of measurement. Now everything makes sense. This is a 500 milliliter bottle of water, okay? I'm going to take the sink and I'm going to fill it up. There you go, to its normal volume. So now I've filled this 500 milliliter. You can read it says 500 milliliters on the bottle. All right? It says it right there. So I've got a 500 milliliter bottle of water. How much does this bottle of water weigh? Yeah, it weighs 500 grams. That's it. I'm done. So if I'm working for a shipping company, there's no math. There's no way to make an error. You have the plastic, and you have 500 grams of water. Because a gram is a milliliter. How much space is this water bottle going to take up when I'm trying to ship it? How many cubic centimeters of space? 500 grams is going to take up 500 cubic centimeters of space because it's 500 milliliters of water. It's all the exact same thing. Does that make sense to everybody? All right, so this is the metric system, and this is the metric system, and that's what it's based on.